What is the main motivation for using synthetic data in AI models, according to the paper?
The main motivation for using synthetic data in AI models, according to the paper, is to address the challenges associated with real-world data, such as data scarcity, privacy concerns, and the high cost of data collection and annotation. Synthetic data offers a solution by providing artificially generated data that mimics real-world data characteristics and patterns. It allows for the creation of large, diverse, and high-quality datasets for training and evaluation, overcoming limitations in obtaining real-world data. Synthetic data can be generated at scale, tailored to specific requirements, and help mitigate privacy concerns by creating anonymized datasets. Additionally, synthetic data enables the development of more robust, reliable, and fair AI models by providing control over data characteristics and improving model performance and generalization.
Can you explain the challenges associated with synthetic data mentioned in the paper?
The challenges associated with synthetic data mentioned in the paper include ensuring the factuality and fidelity of synthetic data, the potential for synthetic data to amplify biases or introduce new biases if not carefully designed and validated, and the misuse of synthetic data that might proliferate misinformation. Additionally, the paper discusses how training with synthetic data makes evaluation decontamination harder, as synthetic data might include rephrased versions of benchmark data, rendering token-level decontamination ineffective. Furthermore, the paper highlights the potential ambiguity in AI alignment introduced by synthetic data, as it may not accurately represent the nuances and complexities of human values and preferences, leading to misaligned AI models.
How does the paper suggest addressing the challenge of ensuring the factuality and fidelity of synthetic data?
The paper suggests addressing the challenge of ensuring the factuality and fidelity of synthetic data by proposing to combine LLM's generation with random walks on knowledge graphs to generate synthetic evaluation data for factuality, which is aware of entities and relations on the graphs. Additionally, the paper introduces a synthetic dataset called LongFact for long-form factuality evaluation, which uses Google Search as the grounding source and LLM for automated judgment to achieve human-level accuracy at significantly lower cost. These methods aim to improve the accuracy and reliability of synthetic data by incorporating external sources of knowledge and leveraging advanced language models for evaluation. By utilizing these approaches, researchers can enhance the factuality and fidelity of synthetic data, ensuring that AI models trained on such data produce more accurate and reliable outputs that align with real-world knowledge and information.
What are the benefits of synthetic data generation techniques in training AI models, according to the paper?
The benefits of synthetic data generation techniques in training AI models, as outlined in the paper, include 1. Abundant and scalable data. Synthetic data can be generated at scale, providing a plentiful supply of training and testing data for AI models, especially in domains where real-world data is scarce or difficult to obtain. 2. Tailored data. Synthetic data can be customized to meet specific requirements, such as ensuring a balanced representation of different classes by introducing controlled variations. This level of control over data characteristics can enhance model performance and generalization. 3. Privacy preservation. Synthetic data can help mitigate privacy concerns by creating anonymized or de-identified datasets that do not contain sensitive personal information. This is crucial in domains like healthcare, where patient privacy is paramount. 4. Overcoming data challenges. Synthetic data addresses challenges such as data scarcity, privacy concerns, and the high cost of data collection and annotation, enabling the development of more robust, reliable, and fair AI models. 5. Enhanced model training. Synthetic data allows for the training of AI models on diverse and high-quality datasets, improving their performance on various tasks and enhancing their ability to generalize to real-world scenarios. 6. Mitigating biases. By carefully designing and validating synthetic data, researchers can prevent the amplification of biases or the introduction of new biases in AI models. Rigorous testing and fairness assessments are essential to mitigate these risks. 7. Cost-effective alternative. Synthetic data is a relatively low-cost alternative to real data, making it more accessible for researchers and developers to train AI models effectively. 8. Improved model performance. Synthetic data can lead to improved model performance by providing a more diverse and comprehensive training dataset, enabling AI models to learn complex patterns and relationships present in real-world data. 9. Control over data quality. Researchers can ensure the factuality and fidelity of synthetic data by developing sophisticated generative models and evaluation metrics, ensuring that models trained on synthetic data accurately reflect real-world scenarios. 10. Future research opportunities. Synthetic data opens up avenues for future research, such as exploring self-improvement capabilities through synthetic data generation and advancing oversight mechanisms for AI models, promoting trust, accountability, and alignment with human values and societal expectations.
Can you describe the approach used in the paper to improve performance on math-related tasks using synthetic data?
The paper discusses various approaches to improve performance on math-related tasks using synthetic data. One approach involves training on math-targeted pre-training data, such as Minerva, Lemma, and DeepSeek Math. Another method is to generate synthetic questions and answers to mimic the training or validation set of target benchmarks. For example, Wizard Math uses GPT-3.5 to increase question and answer complexity, while MetaMath rewrites questions in different ways like semantic rephrasing and backward reasoning. Gary Abel found that augmented answers starting with a paraphrasing of the question followed by a step-by-step solution perform better. XWin Math scaled up synthetic SFT data to 1 million examples and showed benefits for the Llama 2 7B model. MMIQC combined datasets with SFT-style data and high-quality pre-training data like OpenWebMath. AlphaGeometry trained a neural model with 100 million synthetic data points to verify complex geometry problem solutions. By combining synthetic data with a rigorous verification process, AlphaGeometry achieved problem-solving abilities comparable to a human Olympiad gold medalist, showcasing the potential of this approach in enhancing mathematical reasoning tasks.
What are the different methods mentioned in the paper for generating synthetic math data?
The paper discusses various methods for generating synthetic math data. One approach is to train on math-targeted pre-training data, such as Minerva, Lemma, and DeepSeek Math. Another method involves generating synthetic questions and answers to imitate the training or validation set of target benchmarks. For example, Wizard Math uses GPT-3.5 to increase the complexity of questions and answers, while MetaMath rewrites questions in different ways like semantic rephrasing and backward reasoning. Gary Abel found that augmented answers starting with a paraphrasing of the question followed by a step-by-step solution perform better. XWin Math scaled up synthetic SFT data to 1 million examples to benefit from data scaling. MMIQC combines SFT-style data with high-quality mathematical pre-training data like OpenWebMath. AlphaGeometry trains a neural model using 100 million synthetic data points to verify the correctness of solutions for complex geometry problems. These methods showcase the diverse approaches to generating synthetic math data discussed in the paper.
How does the paper propose to mitigate privacy concerns related to synthetic data in the healthcare domain?
The paper proposes to mitigate privacy concerns related to synthetic data in the healthcare domain by creating anonymized or de-identified datasets that do not contain sensitive personal information. This approach is crucial in domains such as healthcare, where patient privacy is of utmost importance. By generating synthetic data that is stripped of identifiable personal information, researchers can ensure that the privacy of individuals is protected while still being able to train AI models effectively. This method allows for the development of robust and reliable AI models without compromising patient confidentiality. Additionally, the paper emphasizes the importance of rigorous testing and fairness assessments to mitigate risks associated with synthetic data, including privacy concerns. By implementing these measures, researchers can address privacy issues and build trust in the use of synthetic data in healthcare applications.
What are the potential risks associated with the misuse of synthetic data mentioned in the paper?
The potential risks associated with the misuse of synthetic data mentioned in the paper include the proliferation of misinformation, ambiguity in AI alignment, and challenges in evaluation decontamination. The misuse of synthetic data can lead to the creation of misleading or false content, which can be used to impersonate real people, manipulate public opinion, or influence political processes, eroding trust in legitimate information sources. Additionally, synthetic data may not accurately represent human values and intentions, potentially leading to AI models exhibiting behaviors misaligned with human expectations, resulting in unintended consequences or harmful actions. Moreover, the use of synthetic data in model training can pose challenges to fair evaluation, as synthetic data might include rephrased versions of benchmark data, making it difficult to detect evaluation contamination effectively. These risks highlight the importance of establishing clear guidelines and best practices for the ethical generation and use of synthetic data to mitigate potential harm and ensure responsible development of AI systems.
How does the paper suggest addressing the challenge of AI alignment using synthetic data?
The paper suggests addressing the challenge of AI alignment using synthetic data by carefully considering the limitations and potential drawbacks associated with using synthetic data in alignment research. It emphasizes the importance of developing robust methods for validating and testing AI models trained on synthetic data to ensure they behave in ways that are aligned with human values and intentions. Additionally, the paper recommends researchers to invest in creating and maintaining in-house and protected evaluation benchmarks to prevent evaluation contamination and ensure the integrity of the evaluation process. By proactively addressing these challenges and limitations, researchers can mitigate the risks of AI models learning from biased, ungrounded, or misrepresentative synthetic data, which could lead to behaviors misaligned with human expectations and potential harmful actions.
What are the key areas for future research highlighted in the paper regarding synthetic data?
The key areas for future research highlighted in the paper regarding synthetic data are: 1. Synthetic data scaling. Future research should investigate the scaling laws for synthetic data to determine the optimal balance between the quantity and quality of synthetic samples, especially in training large-scale language models. 2. Further improving quality and diversity of synthetic data. There is a need to develop new advanced techniques, potentially based on existing ones like generative adversarial networks, GANs, or diffusion models, to control and manipulate specific attributes of the generated data, creating diverse and customizable synthetic datasets that closely mimic real-world data. 3. Towards high fidelity and more efficient scalable oversight, research should explore the use of synthetic data for high-fidelity scalable oversight of complex and autonomous AI systems, aiming to provide more targeted oversight with less synthetic data efficiently. 4. The emergent self-improvement capability, investigating whether models can generate synthetic data better than their original training set, leading to self-improvement through synthetic data generation. This avenue could potentially enable AI systems to autonomously refine their skills and knowledge over time, enhancing their performance iteratively.